What you guys, got another video here for you. Here we have some hardware that I want to test. Now I've purchased this used on eBay and I wanted to do this for a future video, so I thought to show you a video on how I test hardware and make sure that it's not faulty. So when I purchase hardware, which I've already shown you on previous videos on how to buy second-hand used parts, this is what I do now. I snagged this little deal here, which is an MSI Tomahawk B350 motherboard. Also got the Ryzen 2400G processor, which is already in the socket of the board, and also I've got some RGB memory, which is 3200 RGB memory here, which I want to test. Now you need to make sure that you test every component because it's important. When you're buying motherboards, make sure you got the IO shield included. And also there's a hard drive in here, which is I think a Kingston 128 gig hard drive, which will do for what I need for this project. Now I've also purchased an MSI 1070 Ti. Now purchasing second-hand hardware or used hardware is a risky business because some people are in the market to rip people off and get rid of their old junk. Now another thing which you can do is do your research, which I've already made videos to show you. You can see I've got the CPU in the board already and the hard drive is already screwed to the board. I've got some memory which I need to put into the motherboard. And then we can test how hardware. Now I need to obviously put the heatsink here and the back plate on, which I'm going to do. So I just want to take a look first at the CPU. So this is exactly what I would do when I purchase stuff used. So I'm going to take a quick look at the CPU. Now this is an AMD CPU, which means the pins are on the CPU itself. Now sometimes you may see pins on the board. You want to make sure that none of these are burnt or bent or damaged or anything like that. Also check the board for any damage or any burn marks or anything like that, blown caps if it's older hardware. Just going to put some compound on here, and I've just got a bag here which I'm just going to rub around. Now you can use the P method or whatever method you want, it really doesn't matter. I'm just going to quickly smooth this out over the top of the CPU and then screw this heatsink down. Now make sure you've got the back plate with this as well, especially if the back plate has been removed. The back plate did come with this particular motherboard, which is nice. So diagonally I'm going to tighten these down, and you can see now I'm just checking to see where the fan header will go, so I'm just going to put that into there. And also I need to put the RGB lead into the board as well, which will go down the bottom here. Now it doesn't look pretty, but we've got this on a cardboard box, which is totally fine. And what I'm going to do is add in all my peripherals like a mouse, keyboard, and also plug in the HDMI into the monitor and stuff like that, and then we can test it on the box here, so we don't have to start building a computer to test it. We're going to test it right here. Now the next thing I want to do is install some memory here. Now it's important that you test every component if you've bought it used, because obviously there could be one key component here that is faulty, and if you've paid a lot of money for it, then it's not going to be much good to you if that component is faulty. So you can see here I've got everything plugged in now. I've got my power supply, I've got my HDMI cable plugged into my monitor, and also got my RAM and my hard drive all in there. And all I need to do now, I've got my peripherals as well, which is my mouse and my keyboard. So I'm pretty much good to go, and I need to get a switch on here. Now you can jumper the switch on here, but I prefer to use these because it's a bit safer and it stops you from shorting across there. So I'm going to use these micro switch button here, which will allow me to power on the actual board itself. Now some modern day boards have a start button on them, and you can use those so you don't have to jumper them this way, but this one doesn't have that. So I'm just going to push this little button here and we should get power to the board, and it should now start to fire up. So let me just quickly show you the monitor here, and we'll just pan up so you can see it. Now these little switches, I'll leave links for this sort of stuff and links for all this sort of hardware in the video description for you if you're interested in this, but this is a pretty nice little setup. Now this does have Vega graphics on here, but I will be putting a standalone GPU in here. But you can see we do have now a display on the desktop here, which is already been installed with Windows 10 Pro. So here we have it, everything powered up, everything's working nice. So what I want to do now is run some benchmarks. Now it's important that we do some burn-in tests and also some benchmark tests just to make sure and check the stability of the actual system itself. And each component is going to have its own testing. So what we need to do here is go through a bunch of tests. Now this can take a bit of time, but if you're buying used parts, it's really important that you test every single component on that board. So first off, I'm going to run Cinebench here. Now this is a benchmarking sort of software really, but it just gives me an idea how stable the system and setup is. So I'm just going to let this run. Now if there was any instabilities here, this would normally crash, but I'm just going to let this run and see if it completes okay with no problems. And it does, and we can move on to the next test. Next I want to run some sort of CPU torture test, which will be Jam Software's heavy load. You can use Prime 95 or any of those types of software, it's entirely up to you. Sometimes I do use those, I just like to mix it up a little bit. But as long as you max out that CPU, and I'll leave this running for a period of time just to make sure there is no issues with the CPU. And you can see here we're running at 100% maximum load on the CPU, which means that will really tax the CPU, and if there's any issues with that CPU, it would let go or crash or blue screen or something like that. So I'd leave that running for a good 15 minutes. You can leave it longer just to get an idea of stability. You can leave it longer overnight. Another thing I like to do is run HW monitor, and what this is going to do is allow me to check all the temperatures. So I'm trying to get an idea of what the temperatures are like, and you see they're pretty good on every core. We're maxed out 100% and we're getting good temperatures. Next we need to test that memory, and you can use the memory test tool inside Windows. I'm going to do a standard one here, but you can do an extended one if you want to. If it's older memory and stuff like that, you can do an extended one. You can use MemTest software if you want to as well. It's entirely up to you. I'm just going to be running the Windows built-in diagnostic tool and run this. This will take a bit of time, so you just need to let it run through a certain amount of cycles. Normally if you've got really bad memory, you'll get some sort of sign that the memory is bad, i.e. crashing or issues like that, blue screen, and errors will be notified on the screen here. Now it's always important to check your drive, so I'm going to be using Crystal Disk here just to check the drive to make sure the drive's in good order, and you can see it's showing up good, so I'm not worried too much about the drive. And another one you can do is the burn-in test. I'm going to be doing 100% CPU, 100% graphics, 100% disk, and also 100% memory here, and I'll run this, and this will tax the system to the max. And what this will do is generally tax the whole system and find if there's any problems with it. Now you want to run this, and I'm going to be running this for about 15 minutes here, set for 15 minutes. So I'm just going to let this run and see if we get any sort of errors, and this will give me an idea of how stable the system is and whether there's any major problems with any of the hardware in that system. Now again, torture tests and stuff like that, people may leave them running overnight and to test their hardware and to get a general idea of what the quality of the hardware is like. This is pretty new stuff, so I'm just going to give this a 15-minute run here, and this will give me a rough idea of what's going on. But if I've got a suspicion that something is wrong, I can run more further tests, and you can see the tests have passed, and I've got a pretty good pass rate here, which is good. Now remember, we're not overclocking here, so we don't have to do burn-in tests for like 24 hours or 8 hours, what people want to do to make sure the stability is there. This is just stock speeds for the CPU, GPU and everything else, and the memory, so I'm just leaving everything as is and trying to give a rough idea of how good this is. You can see here it gives you an idea, and I've run this for 15 minutes and we've had no problems whatsoever. So remember, I've run other tests as well, and sometimes I run those for 30 minutes or so. But you don't have to overdo things. You can see here that we have got a system that's stable and running pretty good. So there's been no issues at all, no crashing, no stuttering or anything like that with the setup at all. Now this does have Vega graphics built into the CPU or APU graphics, so what we can do here is test an actual graphics card, which I did purchase, which was an MSI 1070 Ti or Ti, depending on how you want to pronounce it, and we want to test that as well, so I'm going to show you how to do that. Now obviously you need to use your common sense here. This is a blower card, and this will get very hot very quickly. And if you're going to torture test this, there's no need to torture it, you know, for 24 hours playing games and stuff. You're soon going to know whether there's issues with it. But what I'm going to do here is put this through a torture test and to see whether there's any issues. I normally run that for about 15 minutes just to see if there's any artifacts or any sort of glitching or crashing on the screen. And I can use Furmark to do this. I'm going to set this up and put in an alarm to make sure that temperatures don't get too high. Now there's not many graphical games out there that are going to tax it as much as this, and you'll see the temperature climb right up to the maximum it can go with this particular type of torture test. And to be honest with you, you don't want to be running this for major long periods of time, because you are going to cause the card to overwork, and you don't need to do that. You just need to see if there's any issues, and normally running something like this will display issues of artifacting and other issues on the screen pretty quickly. So I left that for about 15 minutes. That's normally enough time to get the graphics card nice and toasty, and any gremlins will normally show themselves pretty quickly once the card starts to run beyond its recommended temperatures. So just don't push these tests too hard. You don't want to be running Prime 95 for 24 hours. There's no need, because we're not overclocking or anything like that. And also you don't need to be running torture tests with Furmark for 24 hours, because you are going to probably knacker your graphics card if you keep doing things like that, because it's going to push it beyond its limits. So just use a bit of common sense. All you're trying to do is test whether the card is stable, whether there's any major issues with it, and normally they show themselves pretty quickly when you've got major problems like overheating and GPU issues. Anyway, that's about it for this video. We're just running some benchmarks here. My name is Brian from briteccomputers.co.uk. Hope this one helps you out, guys. Bye for now. Now, if you haven't subscribed yet, hit the big red subscribe button on my YouTube channel and hit the bell notification button next to that to be notified when we upload new videos.